like to welcome everybody to the computer science roundtable discussion. And we've got an amazing panel of folks here, and this is electrical engineering, computer science, and a huge range of areas of research and applications. And we are delighted to have a group of 6 ARCS scholars here today. My name is Kim Polizzay, and I'm actually an ARCS scholar from way back. My background is in computer science and biophysics. Got my degree at Berkeley, studied computer science at University of Washington, and then founded a number of companies in Silicon Valley, and currently am chairman of an AI company using collective intelligence and artificial intelligence to basically predict outcomes. And I am, again, delighted to have an amazing group of scholars here today. And I just love to dive into all of the research that each one of them are doing, but we are time limited. So we are going to really keep the conversation lively and invite questions as well, and keep it interactive. So I invite all of you who are watching with us to submit your questions in the chat, and we will do our best to get to all of them. But to start off, what I'd like to do is ask each of our scholars, and I'm going to go in alphabetical order, starting with Alex, to tell us briefly about the research that you're doing, the work you're doing, and in your field, what are the really big questions coming over the next 5-10 years that you are anticipating, and where do you see the research you're doing going? So maybe just give us a little overview first about the work you're doing. That'd be great.
Sure.
So just really quickly, I'm Alex
There's
Gabriel.
2 Alexes.
Yeah, we'll start with Alex Gabori and then go to Alexander Reinking.
Sure. Sorry.
Okay.
Sorry about that.
Perfect. Thank you.
So just really quickly, I'm Alex Gabriel. I'm a PhD student, a 6-year PhD student at Stanford University. And I work on simulations of specific nanoelectronic materials. But I guess more broadly, I don't know if we have like a big questions in our industry, but we have like sort of these big challenges. And one of them is how do we work towards heterogeneous integrated circuits? So what I mean by that is most of the computer chips you have these days are sort of like in an individual plane, sort of XY plane. But now we have reached some sort of like fundamental shrinking limits as we shrink our devices, our transistors. So getting computation gains is becoming like more difficult. And so one of the things that the industry is trying to do is sort of stack these computation layers, so the memory layers on top of each other, to make computing faster and more efficient. So that's sort of like, how do we do that? It's a large engineering challenge, and so that's something that I'm generally interested in. But there's a $500 billion industry working on this. So what do I contribute to that? Well, in my group, we sort of work on these types of materials known as 2-dimensional materials. So they're like atomically thin, as thin as you can get. And we want to use these to sort of be what we call the back end of line types of devices. So something you kind of like put on top of existing devices and existing computers. But what I specifically work on is I take these 2-dimensional materials, these atomically thin materials. They're very hard to measure. So I use computational techniques to calculate where heat is generated, where heat flows, and how heat can be removed from these materials. So when you actually build a computer out of these materials, they don't overheat, and you don't have issues where your, I guess the computer stops working. And so that's sort of how my research sort of ties into the grand question. Those are very, very big challenges, but I'm working on a small piece, and I think hopefully in 5-10 years that it'll actually be useful, and they start integrating those materials into those computers.
Very cool. And you mentioned in your video, you said this is one step closer to 3-dimensional integrated circuits. I believe you mentioned that. So what does a future look like when we have 3-dimensional integrated circuits? How does that transform computing and the kinds of things we can do in our everyday lives?
Well, I mean, I guess this is not specific to any type of computing. Although if you were to create heterogeneous or the 3D integrated circuits, those are most likely going to be for very high performing circuits. So you probably see them in large data centers or accelerators. And so the types of people that might be using that are other types of researchers. That might be good for like artificial intelligence, any sort of drug discovery. I mean, my own particular field, I use something called molecular dynamics, which is also used for drug discovery. Having faster computers, fantastic for that. So it could help my own research in 5 years. So it's really whatever sort of problems need high performance computing, it will probably affect that first.
So the applications are limitless, in other words. Yeah, very cool.
Yeah, maybe. I wish I could give a better answer. Yeah, it's broadly applicable, yes.
It's a great answer. Well, let's move on now to Alex Reinking and the work that you are doing. Please give us an overview, and then again, share with us sort of where you see your field going and some of the big breakthroughs happening over the next 5 to 10 years, potentially.
Sure. So I work on the design and analysis of domain-specific programming languages and programming models for high-performance computing. So I'm sort of the software side of what other Alex here is working on to some degree. Some of the biggest challenges in our industry right now is sort of overcoming just technical hurdles in actually writing applications that are going to be correct and fast. So sort of the traditional programming models that you would see in like a C or C++ program, say, require an intense amount of manual effort to optimize to each individual target you might be interested in. So if you want to write one application that runs well on a phone versus on a desktop versus in a data center, that's quite a bit of engineering. You basically have to start from scratch every time. And so this language that I work on, Halide, papers over a lot of these differences by allowing you to specify the what to compute separately from the how to optimize it. And this programming model then lets you sort of safely retarget the performance properties of your program to each of these different architectures, and not worry about whether or not your outputs are going to change, or if you're going to introduce a bug or basically increase maintenance costs a lot. Kind of going forward in the future, we're interested in extending these ideas to heterogeneous computing architectures. So we might want to have a single program that runs across multiple computers in like a supercomputing cluster, each of which might have multiple CPU cores and maybe a graphics card on each node. And we want to be able to balance workloads across heterogeneous platforms. And then on the other side, we want to be able to make these ideas more modular and reusable for hardware and software co-design. So we might want to start spinning up systolic arrays or FPGAs that have programming models that are easy to schedule and easy to program with this sort of unified framework of separating algorithms and their optimization strategies. And basically building systems that have bespoke pieces of hardware in with the rest of the other heterogeneous pieces. That's what we're working
Super
on.
cool.
Yeah.
Super cool. And by the way, I want to invite other scholars here to ask questions as well and make this interactive, because the work, again, you're doing, each one of you is really interesting and relevant, to the entire to a broad set of applications that where I think that there's some overlaps. So when you think about sort of 10 years, 5-10 years from now, where this goes, Alex, sort of what are the big developments in the work that you're doing that you anticipate?
Well, ideally, we'd be looking at a world where it's much easier for programmers to write high-performing software that uses very little power.
Yeah.
That's kind of the direction we're just pushing in very steadily. And sort of with the end of Moore's law, with our diminishing ability to put transistors closer together and get higher clock rates out of hardware, it just is becoming more and more important to be able to program new bits of specially tailored hardware to certain tasks.
Right.
And lowering the barrier to entry for that sort of thing is something that is bolstered by having well thought out programming tools.
Yeah.
That's what I'm interested in building. Yeah.
Love it, love it. I led the launch of Java at Sun back in the day, so I have love for programming languages and the evolution of them. And I'm delighted to hear about the kind of work you're doing, because it felt like for a long time there wasn't a lot of evolution happening, and in particular the high performance area that you're working in is really breakthrough stuff. So thank you for sharing that with us.
Sure.
So Aviv, please, again, share what you're doing and where you see it going, sort of big breakthroughs or questions ahead.
Sure.
Please.
Yeah. Hi, everyone. So I'm a second-year PhD student at the UC Santa Cruz Department of Computational Media. My research really focuses on how can we take like emerging forms of media like virtual reality to create serious applications in healthcare and assist users. And so I guess if I had to like pick one of the really big questions that is driving this research, we're seeing that virtual reality is becoming increasingly more, ubiquitous, immersive, and engaging. If we can simulate most any reality through these virtual worlds that are increasingly being more meshed with our real worlds, what would be the best experience to assist users? And so for a specific example of what I'm working on, how can we assist users for physical rehabilitation? So in this context, the work that I do is I go to therapy clinics and I work with stroke survivors to see how can we use all this data that we can get out of VR to make these environments more emotionally and physically intelligent, but how can we also design games to make the exercise just a little bit more fun and enjoyable for these people that are repeating these exercises multiple times a week? So yeah, that's a little bit about my work.
And do you see this as sort of transforming the field of rehabilitation, physical therapy? Like if you imagine physical therapy, in a decade or maybe 15 years from now, what does it look like as a result of the kind of work you're doing and others like it?
Definitely. Yeah, I think one future for physical rehabilitation with these headsets would be for you and I to meet in a virtual room, to be able to walk around each other, for you to be able to replicate a lot of the in-person success metrics that therapists need without the equipment that costs thousands to even hundreds of thousands of dollars. Just being able to meet in the same room, regardless of location, getting the metrics that you need, but also having these environments help me when I'm not meeting with therapists. Adapting to how I feel every day, whether I need to push myself a little more to complete my exercises, or whether I just, want to be more engaged with these exercises through some sort of narrative or game mechanic.
Right. That makes a ton of sense. And it strikes me the combination of the kinds of remote workout tools now that are emerging and something like this, where you don't have to go to the physical therapy office anymore because it's all where you are. It is wherever you are. And I think also another interesting part about this is just the making it fun and engaging, where physical therapy has never been that. And a lot of the problem in PT, of course, is just adherence, getting people to keep doing their exercises, which can be incredibly powerful, but it's really hard to get people to stick with it. So very, very cool stuff. Well, let's move on. And Molly, tell us about the work you're doing and where you see it going.
Yeah, sure. So I'm the large overarching theme of my work is human-computer interaction. So looking at the ways we can design interfaces of computer systems to make them usable, functional, and fun, as I think Aviv also works on. And specifically, I'm interested in broadening the landscape of what even we consider to be computational interfaces. So, and bringing a richer landscape to bear on that. So for example, we do a lot of work with non-computational artists. So we'll work with a performer who doesn't consider themselves a computational person at all. And we ask them about their creative practice and how they engage with their practice. Sorry, my neighbor's doing a lot of work. And we think about how that practice could be integrated into a computational system that would then scaffold newcomers or support people in developing a lifelong engagement with practice. And so that's one direction that I see the design of computational systems going, is kind of looking beyond the screen and maybe going into embodied interfaces and really leveraging the way that we interact with the rest of the world and sort of bringing that into the design of computer interfaces. But the other piece that I think is really important is really using computers and the design of computational systems to fix a kind of, to the extent that they can, bring a lot of those systems into bear on and address current inequalities that exist throughout society and sort of start to even out these current inequalities. So for example, right now we have a lot of systems that will do like recommendation systems or recommendation applications, and they use algorithms trained on existing data. But that existing data is based on problematic, racist, sexist data. So we could fix that in other ways. So I think that's my longer vision of where HCI is going, is to kind of help address a lot of those inequalities.
Very cool, very cool. And again, I invite other scholars to ask questions here, because there's so much that's sort of intersecting and overlapping about where some of the stuff can go. So please feel free to, anybody. And Molly, how did you come to work on this, and sort of what led you to this interesting, just unusual area of human computer interfaces?
I'm so glad you asked that, because what brought me to this is that I actually really hate technology and I really hate computers. So I want to fix them by destroying them all.
Yes.
So that's why I'm here. I'm here to ruin computers as we know them.
Well, that's the kind of design thinking you need. It's just like, let's rethink everything, right? Why should they work this way? And I know we all have our frustrations with technology and computers, and so that's music to my ears. Well, let's move on, and thank you. Let's hear from Pablo. Please share again what you're doing and where you see the big breakthroughs happening or questions emerging over the next decade or so.
Absolutely. Well, thank you. Yeah, my name is Pablo Vlastos. I'm a third-year PhD student at the Autonomous Systems Lab at UCSC. And right now, my research encompasses designing autonomous surface vehicles, or small autonomous boats, to do surveys, to do ocean mapping, and to collect a lot of ocean data. And so our lab is all about autonomous vehicles, obviously, and we have UAVs, we have ASVs, ROVs, all of the autonomous vehicles you could imagine. We have those kinds, and we use them to do research on a number of different things in a kind of a holistic way. We look at attitude estimation. We look at how can we code these to be more efficient and more versatile in different environments. And one of the things that we're looking at right now is how can we do spatial estimation and explore new environments. So maybe you have an autonomous vehicle on another planet exploring the oceans of some moon of Jupiter or Saturn, and we have like methane oceans. You have to have a very robust system to do that. Now, bringing it back home, we're looking primarily at oceans and other parts of the environment that we have UAVs that might explore regions that have burned or are prone to forest fires. And I think where the research is going now is specifically kind of going back to what both of the Alexes were talking about, is having very efficient hardware and very efficient coding methodologies. And I know I've kind of oversimplified that a little bit, but we're trying to have very efficient embedded systems that don't require a lot of computational overhead, but can get the job done. And so we do, a lot of microcontroller-based system architecture. And if we can push the bounds of having very efficient and very, low computational needs or compact computational needs, we could lower the cost for all these autonomous systems and collect more ocean data in situ, which is, has some advantages to satellites, not entirely. But I think that's where the research is going, is trying to get many more out there into these environments at lower cost, and trying to use that data combined from all of these vehicles. So yeah.
Excellent. And do you have did I remember right, do you have a background in aerospace engineering?
So my background's in robotics, but I've always had a passion for aerospace. So and I find more and more overlap with that all the time. So it's, it's definitely related.
Yeah, I'm always so interested in sort of what leads to people to the work they do and the research that each one of you is working on. So I was curious whether that was an inspiration that led you to doing what you're doing. But that's awesome. And again, like you said, there's so much of the theme here today is really about, low energy consumption, high performance, doing more with less, energy consumption, and designing systems that are smaller and smaller. So this is really all about enabling, the next generation of all of the applications that will depend on computing, which is pretty much everything. So the work that you're doing, each one of you is going to be having just profound impact across a wide range of applications. I know that you can't even imagine yourselves probably now. Let's also just make sure if anyone's keeping an eye on the chat, if we have any questions, I want to make sure to surface them.
Oh, yeah, I've been looking at it. So far, I don't see any new ones unless it didn't update for me.
Okay. And I know that this is actually going to be, I know there will be a lot of questions that people have once they see this, because this is going to be posted online. So this is really an invitation for people to learn a lot more about your work, this discussion today. But I want to go around one more time and ask you again, if each of you can talk about kind of how did ARCS help you, and where do you see yourself going over the next, decade or so? Do you imagine staying in research and academia, or going into industry, or do you even know? I know it's hard to know at this point. You're just focusing on the work you're doing, but I'd love to hear a little about how ARCS impacted you. I can think back to my experience with ARCS, and it was such a surprise to get the call like, oh, they're noticing me and the work that I'm doing. Wow, this is really nice. Plus, of course, it's financial help. Sometimes, that can really make a difference, particularly in the past year. So I'm really inviting each one of you to talk a little about sort of your personal experience, both getting this award and then where you see yourself going. And if you want to talk about the impact it's had also during the pandemic, it's just been a strange time. So please feel free to share your thoughts on that too. But why don't we start again with you, Alex Gabriel, please.
Thank you. Did we get to Ryan before for the intro though?
No, we did not.
Did we miss Ryan? I'm so sorry. Oh, good grief.
That's okay.
Down far enough. Ryan, yes, please. Thank you, Alex.
Yeah,
Share
thank you.
with us what you're doing and where you see it going.
Sure. So hi, everyone. I'm Ryan. I'm a third-year PhD student in the Hybrid Systems Lab at UC Santa Cruz. And I work in what are called hybrid systems. So those are systems that contain both continuous time and discrete time dynamics. And in some senses, this is a more theoretical side of the kind of similar kind of work as to what Pablo's doing. So a lot of and I guess specifically in that regime, we focus on developing controllers for hybrid systems, and then studying the resulting closed loop stability properties. And that's a useful field of study because obviously real life systems, let's say a car or a computer or something, its state evolves continuously in time. But then oftentimes we control these systems with a computer, which has some frame rate associated to its computation and its logical processes, so that evolves discretely. And the interaction of a discrete time controller with a continuous time physical process is actually quite complicated. And in previous, last 100 years or so, a lot of control design and analysis has been performed by considering everything to be continuous or everything to be discrete. And that works pretty well for relatively simple systems. But you can actually come up with cases where if you discretize both your physical system and the controller for the system, everything looks great in like a discrete time representation, but then you plug the thing into actual hardware and it's totally unstable. So it's useful to consider the intricacies in those interactions, but it's also complicated, right? I mean, a lot of the notions of stability and robustness that we've developed for continuous or discrete systems just don't work anymore when you consider a hybrid system. So we're working on kind of reforming the foundation of control in the sense of a hybrid system so that we can hopefully develop kind of more robust and more capable systems in the future.
Fantastic. And tell us a little about your background and what led you to the work that you're doing now.
Sure. So my background is also a fair amount of aerospace. I've worked at a company called Moog for about 4 years. So they make actuators and gimbals for aircraft, mostly for both commercial and military applications. And then I've interned at the Jet Propulsion Lab. It's one of NASA's facilities in Pasadena several times, working on the NICE spacecraft and also the Perseverance rover that just recently landed on Mars. So I've very much enjoyed that experience, and it's certainly something I hope to do more of in the future.
Fantastic. Thank you. So yes, Alex, if we could go back and just again, this is about a little bit about yourself personally, where you see yourself, you know, from a career standpoint, you know, continuing the work you're doing and in beyond, and also the ARCS award and what that has meant to you.
So I guess as far as what my plans are, I guess I'm still interested in that grand challenge of 3D integrated circuits, or at least something along those lines. I think upon graduation, my research or my direction will shift a little bit. I'm going to be working on that type of problem, but I'm going to be attacking it from a different angle. And actually, a couple of colleagues and me are going to create a startup. So we're going to go try to do something on our own and solve a problem in hopefully a unique way. So who knows where that's going to lead, but that's our initial plan. So I think that's exciting. But now as for how ARCS has helped this last year, well, you know, COVID is a difficult, challenging year, and so just obviously having ARCS be there and provide some stability, financial stability. So I don't have to stress about that. I know I can just work on this stuff was, I mean, I can't even gauge how useful that was for me. But if we sort of set that part aside and just sort of look at it from the research standpoint, ARCS felt like it was, you know, it really supports just the person. And there's such a diverse set of ideas. They don't really have any specific goals that they're going for. Just say like, we think you're a good scholar. We're going to give you some funding to support your ideas. And I think that really helped because I had the freedom to pursue the things that I thought were important, not maybe some different agency, or, you know, I guess it was possible that I maybe didn't have funding. So
Yes.
So it was really nice for me to sort of take some time, and I spent time working on some computational methods, and, you know, I ended up writing something that was I'm very proud of, and it's very fast, and something that I wouldn't have had the chance to do if I was on a different funding source. And so ARCS has their flexibility and like just sort of trusting us to do the right thing is actually enabled the good stuff to come out of the end of my PhD. And so I'm very grateful for that.
That's terrific. And you're right. And ARCS is unusual in that way. Thank you. Thank you, Alex. And Alex Reinking, if you could share with, your thoughts on that.
Yeah, definitely my experience with ARCS has been very similar to other Alex's. I think I just add that probably the biggest impact ARCS has had on my my research career was right at the beginning, when it afforded me the opportunity to find my current advisor, which was a kind of a 1.5 year long process of working with several different professors and just kind of getting locked into a project and research group that I thought was going to be really exciting and really fruitful for the next 4 or 5 years. And I don't think I would have had that opportunity if I had to worry about teaching to make ends meet or anything like that. So yeah, definitely very grateful to ARCS for even being able to have this advisor match in the first place. Which was great. As for me personally, I've already got some industry connections at Microsoft Research. So if I had my way, I would join the research and software engineering group there after I graduate, which will hopefully be next year. Lots of open questions here, but that's kind of where I'm aiming.
Awesome.
So we'll see how things shake out.
That's wonderful. Cool. Thank you.
Mm-hmm.
And Aviv, tell us about you know, again, impact of ARCS and kind of where you see yourself going.
Yeah, I mean, I think ARCS just provided me invaluable support at a time when I really, really needed it. And thanks to that support, I feel like it really just pushed my research forward and even kind of impacted my future career. Just to give some context, this past summer, through the support of ARCS, I was able to interview 130 rehabilitation professionals, from physical therapists, occupational therapists, to really understand how is physical rehab going during the pandemic, because what we're doing right now, this is physical rehab. I mean, these clinicians, they lost their hands-on tools. They were lost out of a job. Their clinics were being shut down. Their patients couldn't be seen. And so really it opened my eyes to just how we need to advance our remote tools to help with physical rehabilitation. And so we're working on kind of replicating those in-person success metrics that therapists need through these VR environments, given the gains that we already have. But through this entire process, we were actually invited to participate in the National Science Foundation I-Corps program. And in short, we kind of formed a startup, and we were just recommended for funding to create tools to give therapists the ability to do better remote physical rehabilitation, to meet with their patients in a virtual room. Yeah, I mean, I'm so grateful to be here, to be talking with y'all as an ARC scholar, and it's something that I'll always remember.
That's awesome. And yeah, it's interesting how just, one, a scholarship can break through, can create all sorts of new opportunities you couldn't imagine. So I love hearing that, and particularly, the kind of work you're doing, which is, does change lives. So awesome. Molly.
Oh, excuse me. Yeah, I think for me, the biggest huge impact that ARC's had is when you have external funding, it sort of takes a huge amount of pressure off, as I think a lot of people have expressed. And so I didn't come from a research background. I used to be a professional performer. And so coming into the world of research was a huge shift, and I had no idea what I was doing. And of course I came with my own kind of like expertise and perspective on things, which was why there was a lot of benefits to that as well. But it was kind of a, there's a certain amount of challenge of learning a whole new language and learning a whole new culture, really, and learning the whole new processes and ways of learning knowledge, and even like the words that you use to explain the stuff you're talking about. It's really a whole different ballgame. And it took me, I'm year 5, and I feel like I'm now starting to know like how to kind of like, I'm starting to figure out how to do it. And I would not have felt like ARCS really gave me kind of the runway to feel like I had the space and the time to do that.
Yep.
And I think especially for people with unique backgrounds, people from underrepresented groups who didn't have that support before. Like I was on the application committee where I was helping to decide who would get accepted to UC Berkeley in the past. And people are applying as a first year with multiple first author publications. I mean, people are coming in with huge amounts of experience, which is wonderful for them. I'm very happy for them, but that's not where I came from. And so when you have this kind of support, it really enables people from all kinds of different backgrounds to really get engaged in research, which is what the world really needs, to like have so many different people engaged. And I think ARCS really enables that in a different way than yeah, it's just very, very important. So
Right. Well
valuable.
said. Well said. Thank you.
And in terms of future plans, also Microsoft, or maybe Cirque du Soleil. They just reopened, so maybe they can hire me now. I don't know.
I love the range of options.
Yeah.
Microsoft, Cirque du Soleil,
Yeah.
That's
Who knows?
really cool. And it just reminds me of this quote Yo-Yo Ma has been referenced or credited with, which is all the interesting stuff happens at the intersections and the edges. It's like different disciplines intersecting and then really pushing the boundaries of disciplines. So exactly. Excellent. Thank you, Molly. And Pablo, share with us your thoughts on this topic at hand.
Oh yeah, definitely. The last year has been, to put it mildly, super crazy. I literally have a 7-foot boat in my room because that's the only place I can work on it at the moment. So like I've had to do a lot of hardware stuff where I sleep. But throughout my graduate career, I've had to be a teaching assistant, and that's been a very rewarding experience. But thanks to the ARCS Foundation, I've had an opportunity to really hone in on my research, and that as Molly pointed out before, having that ability to hone in on something and free up that time has been like invaluable. I've made a lot of progress just in the last, in the last few weeks alone, thanks in part to the ARC scholarship. And meeting my sponsor was, a very special event. And, I've already made a lot of connections as others have expressed already. It's been quite a rewarding honor. And I think it's super exciting. And I hope that, we can talk to the future ARC scholars too, and see what they're up to. Also, Ryan, I'm going to have to send you some messages, or we'll have to meet offline at some point. I've got so many questions. Yeah.
Sounds good. I'd like that.
Awesome. And there's a LinkedIn group, by the way. We're getting better at getting people together and sort of connecting people in the ARCS community going forward. So I encourage each one of you to not only, connect with each other here, but also join the LinkedIn group and, all of the opportunities to continue to be part of the ARCS community, which is a really wonderful community, which is why all these years later, I'm here with you. So super, super encourage that. And Pablo, anything else you wanted to mention about what you see yourself doing? I'm not sure we heard that.
Oh yeah. So I actually have an interview with SpaceX a couple weeks from now. So I'm hoping to see how that goes. I have to go present to them, but I'm definitely, as you mentioned earlier, I'm really interested in aerospace, and there's been so much overlap with that. So that's kind of the trajectory I want to go on next. And I think there's a lot of potential there, especially in the commercial space industry. And I guess from my background, that might show that too.
Awesome. Awesome. And Ryan.
Sure.
Please.
Well, good luck, Pablo, on your interview, first of all.
Yes.
Yeah. So I mean, the ARCS funding is important and impactful in any year, clearly, but I think this year, more than most, it was certainly a blessing to all of us. I mean, I guess prior to the pandemic, I did the vast majority of my work in lab, just because it's nice to kind of separate home life and work life. But that also meant that once I'm forced to stay at home for a year straight, I wasn't really set up to work productively here. I mean, the internet at my house was terrible. My monitor screen was tiny, various other issues. So having ARCS funding available to help me kind of transition into a productive work from home life for a year was extremely helpful. And then not having to really concern myself too much with financials in the middle of a pandemic allowed me to maintain some sense of productivity in my research, which was incredibly helpful because I mean, this year is my dissertation proposal. So I was actually able to make like a significant amount of progress towards that, largely due to the flexibility that was provided by the ARCS funding. So I very much appreciate it.
That's awesome. And what about plans ahead? Any thoughts about what you might do next?
Yeah, so working at NASA has been my dream job since I was about 10, and is largely the motivation for becoming an engineer in the first place. So I'm still steadily working on that path, hoping after I graduate that I can end up at JPL or similar NASA center.
Yep. Fantastic. Well, I know we're running out of time here, so I want to bring this to a close, sadly, because there's so much more we could talk about, in particular about really diving into each one of the areas of research you are all working on. But I just want to thank you for being part of this conversation and for just sharing a little also about yourselves and what ARCS has meant to you, getting this award. And again, I want to encourage you to continue to stay connected, join the LinkedIn group, and we'll find ways to continue to have interactions between ARCS scholars. We're doing a lot more of that these days. But if there's anything that we can do as an organization to improve communications, please let us know. We're all ears. And again, congratulations to each one of you. It's just a huge honor. And I am so impressed with the work that each of you are doing. And so glad that you shared it with us today. So thank you all. And have a wonderful evening. And I'll be seeing you, I'm sure, at more ARCS gatherings. Let us know also if we can be of any help. I'd be happy to continue to stay in touch with each one of you.